Hello everyone, my name is Jennifer McGee and I'm super excited to be with you all virtually this year for the Scottish Summit in 2021. This session is titled Floodwatch Monitoring and Observations for a High Hazard Dam, an O365 solution plus Logic Apps. I'm excited to be sharing how we have been using Office 365 for this project. Before I get started, I wanted to say thank you to all of the conference sponsors this year: Script Runner, DQ Global, Proximo 3, Redspire, Agilicis, and Hitachi Solutions. I really enjoy participating in these types of events, and I'm glad that registrations continue to be free for attendees due to the generosity of these sponsors. So a little about me. As I said, my name is Jennifer McGee, and I'm a water resources engineer with Wood. While our company headquarters are in Aberdeen, Scotland, I work out of the US DC office. Most of my engineering work is related to floodplain management, including hydraulic modeling, watershed planning, and flood forecasting. All of these projects rely on effective use of technology for data collection, analysis, and reporting, making the Office 365 platform a great addition to our use of Excel, GIS, Python, and other tools. In addition to my engineering work, I'm also the digital skills lead for our consulting business unit and host our monthly Office 365 user group meetings. My goal for this role are to raise awareness for digital technology in the company and also support staff learning how they can use the low-code, no-code options of Office 365 in their projects. My LinkedIn profile is at Jennifer R. McGee. If you'd like to connect, send me a message there and let me know that you saw this presentation at the Scottish Summit 2021. The outline for this presentation will follow 4 general categories. The first, definitions. 2, project objectives. And the third, we'll do an overview of the monitoring system. And then lastly, I'll dig a bit more into some of the design highlights and other tips for each major component of the project. So first, what is a dam and what makes it a high hazard dam? According to Webster's Dictionary, a dam is defined as a barrier preventing the flow of water or other loose solid materials, such as soil or snow. And more specifically, as related to civil engineering, a dam is a barrier built across a watercourse for impounding water. Dams can be made out of many different types of materials and are uniquely shaped to fit the local topography. Therefore, what classifies a dam as high hazard isn't what they are made of or how they were built, but the classification is focused on the potential of that structure to cause loss of human life or damage to critical infrastructure if there was a failure. Locally, the Virginia Dam Safety Act requires these types of structures to be monitored during flood watch alerts and other high-risk events so that mitigating actions can be taken immediately should there be any indication of a weakening of the structure or failure. The most common scenarios you might envision of a dam failure is of water rushing over the top of the spillway due to heavy rainfall. While that is one scenario, a dam can fail for a bunch of different reasons. The more subtle ones include cracking, piping, and seepage. These are all different ways that allow water to work its way through the substructure. As the water level rises in the pool behind the dam, the water pressure against the bottom of the structure also increases. This pushes even more water through this tiny network of cracks in the soil or concrete. Poor maintenance of vegetation and wildlife can also contribute to the weakening of a dam. As roots grow, they can create avenues for water to travel through the structure. Animals that burrow into the soil can also create weak spots. So while this presentation is focused on our flood watch monitoring, it's worth pointing out that these other contributions to weakening of a dam structure can cause what is known as a sunny day failure. These are particularly dangerous because they are more unexpected. In the U.S., the National Weather Service is a division of NOAA, the National Oceanic and Atmospheric Administration. The National Weather Service is responsible for issuing safety alerts for severe weather. Related to flooding, they have 4 primary categories. They are flood advisory, flood watch, flood warning, and flash flood warning. A flood watch is specifically for when conditions are favorable for flooding. It does not mean flooding will occur, but it is possible. A flood advisory is a little less severe and is issued when a specific weather event that is forecast to occur may become a nuisance. A flood warning is more severe and is issued when the hazardous weather event is imminent or already happening. And then lastly, a flash flood warning is issued when a flash flood is imminent or occurring. In order to meet the monitoring requirements during flood watches, this project had 5 main objectives. 1. We wanted to alert the client and the on-call team as quickly as possible after a flood watch was issued by the National Weather Service. 2. We needed to coordinate an on-call roster that rotated weekly, therefore always having a team of staff ready to respond to an alert. 3. Observations needed to be completed every 6 hours within the watch period, so the process needed to set a deadline for the first observation and then track as each observation was logged and set the deadline for the next one. 4. To keep the whole system digital, we wanted a phone-based app to record all field observations. And finally, we wanted to make sure that the client, project manager, and on-call team all stayed informed of the actions being completed throughout the watch period. While each Office 365 application can be used on its own, they can be even more powerful when they are designed to work together. For this project, all data is stored in a set of SharePoint lists for alerts, observations, and staff contact information. Azure Logic Apps is used to monitor the National Weather Service API and trigger our project workflow when a new flood watch alert is posted. A Power App is used to collect the field observations. It also includes additional information about the active alert, historical observations, and contact information for the on-call team. Behind it all is a set of 4 additional Power Automate flows that send out relevant notifications to the client, project manager, and on-call team as each action is completed during the flood watch period. In this next section, I'll review each Office 365 application used in this project and point out the main details of each design. The goal is to show how they all work together in the context of this project. So in order, I'll be showing first the SharePoint site and lists, then the Logic Apps trigger for the National Weather Service API, third, the rest of the Power Automate flows, and then finally the Power App that brings it all together on the phone. Like every data-centric project, this one started with defining the data schema, building a SharePoint site for the team to collaborate, and finally building the SharePoint list that all of our data would be stored in. So switching over to SharePoint now, I'll show the layout of the project page and cover each of the 4 lists: watch alerts, observations, contact info, and the on-call schedule. So here looking at our SharePoint site, this is a demo version for this presentation, but it actually does fairly well mimic the same layout we have on our project site, where we have high-level information right here on the center of the home screen, so you can very quickly get to either, in this case, the conference or our project back to the client site and relevant information that they've provided for the project. But we can also create an alert. So this links to the form then that will allow you to manually create an alert of your own choosing. You can also then view all alerts that we've had on the project, whether it's active or any of the historical ones. Same thing too with viewing all observations, whether they're the current ones or ones for a previous alert. And then we can view all the team contacts. So if we need to add people from the roster or update emails, phone numbers, any of that can be managed right here from the center of the home screen. This middle section focuses on an active alert. So you can see here where we have an alert and then we have an update to that alert. And this will give you at a glance what is the watch period, is anything changing between the first alert and any subsequent updates. And so you can quickly see any relevant information here if you're just monitoring the SharePoint site and not actually out in the field. And then on the right, we have all observations related to the current active watch as well. So our key data point is the water surface elevation reading. So that is the pool level in the reservoir behind the dam. And it logs, when that was happening. And so we can at a glance see if we're getting better or if we're getting worse through a watch cycle. And then the bottom here shows the roster schedule. So again, just showing the next couple of weeks. Our handoff is every Wednesday at noon, so the project manager can come in and see, hey, who's on deck, or who's on call, sorry, currently this week, and then who is up for next week and then the following week after. And if there's any holes like there is currently in this one, they can work on actually getting those positions filled to make sure we have full coverage on the project every single week. So now looking a little bit more into the details of the list, a lot of this, again, is probably fairly straightforward for folks familiar with SharePoint, but the idea is that we've got a title field, we've got an update for the alert type, whether it actually is a regular alert or an update. We know when it's been posted, when the watch begins, when the watch ends, and we've got a full detailed description from the National Weather Service API talking about what rivers are impacted, what areas of the county, potentially timing or flood stage elevations if they know that. And so this is information that staff can fall back on to get more detail on the current alert cycle. And then it will confirm here whether the Logic Apps posted this alert or this was one of the ones that we created manually. And along that, we also get an event ID and a reference ID. And in this case, you see the reference ID for the update matches the event ID for the original alert. So we can very easily correlate those two and know that they go together. The observations list, again, is also fairly straightforward, where we've got a connection back to our alert based on the same title. And then we have an observation date and time, who made the observation, check mark for yes, no if the HASP was reviewed. And this, really critical field component for us to make sure that everyone takes proper safety precautions, especially since we're usually out in the dark, in the middle of the night, pouring down rain. Really never know what you're going to expect. So make sure folks are taking safety precautions. Log the actual water surface elevation, and then any subsequent notes of the conditions in the field or potential concern that we want to pass on to the client. Those notes do get included then in those email messages that go back out to the team for every observation that is logged. So mostly straightforward text field, date fields, very, very simple data types here. The team's contact list, again, nothing fancy. We're actually just going to skip it. It's names, emails, and phone numbers. And then the last one here is the roster schedule. Again, I did not fully populate this for the demo, but the idea is that each schedule will have a unique name so we can easily identify where we are. It has a start date and an end date time. Again, we've set it for Wednesday at noon for the handover from week to week instead of on the weekend. Now that we have a framework for storing our data, we need to start populating it. The staff contact information and the on-call schedule are managed by the project manager. The next step to tackle is populating the flood watch alerts. Now there are several ways you can be notified of a flood watch alert in your area. You can hear it on the radio, see it on the news, sign up for an email alert, and probably a few more ways. The downside to most of these methods is that the alert can be easy to miss, or even if you see the email, you have to manually take action to log it into SharePoint and then notify your team. Programmatically monitoring a reliable API allows for a hands-off solution that can immediately log the alert into SharePoint. Programmers may be familiar with how to do this in Python or other programming languages. Because we wanted to work within the Microsoft 365 platform, we originally looked at using the HTTP trigger in Power Automate. This, however, is a premium connector, and we didn't have a premium license for this project. We did, on the other hand, have access to an Azure account. Therefore, we ended up using Logic Apps instead. The same HTTP trigger is available there without any additional licensing. We just pay per use to run the Logic App flow. So a quick cost comparison. Even with running the flow every 30 minutes to check the API for a new flood watch alert, the total cost has been less than 50 cents a month. In this demo, we'll look at several key pieces of this workflow. It of course starts with the HTTP trigger. Then we'll look at the JSON response and some tips for how to read it. We'll check if any of the alerts were found, and if so, the workflow will log the alert into a SharePoint list and also save a copy of the JSON response as a text file for future reference. The last step is to post a message to the Teams channel, confirming that it ran successfully and provide the number of alerts that were found, which is usually 0. So getting started here with the Logic Apps Designer in Azure, we're going to go ahead and take a look at the flow that basically triggers our entire workflow. And as I mentioned before, it starts with an HTTP GET request. And so there's multiple types of methods there as I just showed, but GET is what we're going to be used for this example, and probably what you use for most URL requests. The URI there is an address that was provided to us by the API documentation, along with the query parameters to get the event and the zone of interest. So a couple of standard headers there, and the fact that this runs on a schedule is awesome, so we can set it to automatically run every 30 minutes and check the API to see if it has any data. And so now in the flow, we basically need to then parse the JSON response that comes back from the API in order to have any data in a way that we can work with it in the dynamic content tags and then make decisions based on what information we actually found. So reading actual JSON can be a bit tricky though if it's not something you're already familiar with. So the best thing to do is usually to look at your data in the browser or through another mechanism that you have before trying to build your flow based on that data. This is a good example here, where I'm looking at my query, I know it's right, but it's not returning any data. The features dataset is blank. So it's really challenging to build a flow with dynamic content tags when I don't know what the full JSON specification is going to look like when I actually have a flood alert. And of course, I can't just demand a flood alert on the fly, but what I can do is just look for any flood alert, whether it's in my zone or not. And so this is a great example of where you can borrow data from another very similar query to get the JSON structure you need in order for your flow design to work. And here there's a ton of information embedded into this JSON return, way more than what I actually need. But we are pulling out some key information, one there being the event, clarifying that this is for a flood watch. And we've got a bunch of different dates and times for when the flood watch starts, when it ends, different headlines, descriptions, the area that is impacted, and a lot of other very useful information for us. But if this is still a bit tough to read and kind of follow and understand what's important and what is, tag and what is text, and it's not super clear for everybody. One trick, as I want to mention, is that you can use that same URL and post it into Firefox, and it will naturally parse the JSON response for you to look like what you're seeing here, where all of your tags or your descriptors are in blue along the left, and then all your values and actual text information is in pink on the right. This is actually still the first one. It was empty. So when we switch the URL just to look for any flood watch alert, now you actually see it fully populated with data like we did in the previous screen. So here again, we see our flood watch event type. We see a headline with a brief information, some other descriptions, again, dates, a bunch of information. But what's really cool about looking at it this way is now you can start collapsing areas that just have information that you're not currently interested in. So that way you can see more of what is relevant on the same screen at one time. So this is super helpful when you're trying to figure out what does your data look like so you can build your flow appropriately. So yeah, tip, check out Firefox if you don't typically already use it. It can really come in handy when you're working with JSON data. So the next step in the flow here is just to catch the red arrows indicate that it's a run after if this previous step fails or is skipped. And just from learning the hard way, the National Weather Service actually changed their API after we started building this flow, and so it started crashing and I didn't realize it. And so now this will help warn me if they change the schema again. I will know immediately and I can go in and fix my flow. And so the compose there is just checking how many flood events did this query return, a condition statement to check to see if it's 0 or something more. And if there's nothing, it just logs into SharePoint saying, I checked, and it posts a message in Teams saying, yep, no flood alerts currently active for our study region. If the number of features returned is greater than 0, then obviously we need to take a few more steps to actually get this logged. And one of the things that may not have been immediately obvious is we needed to check to see if our SharePoint list already has a record for the same alert, right? Because this thing is going to check every 30 minutes, and the API just posts, say, yep, there's an alert. Occasionally it'll post updates, but it's really just the same information the flow is getting every 30 minutes. So it's going to check SharePoint first to see, is this an existing record? If so, it won't duplicate it. But if not, then it will go through the steps to actually then post a new alert to our SharePoint. And so this condition, again, is just checking if the length of return is equal to 0. If it is, it actually says that, hey, this is a new alert. We need to go ahead and create that item in our list. And then we're creating that backup file of the raw JSON. So if we ever need to reference that later, we will have a copy of it. And if the result is something greater than 0, then we just confirm to our team, hey, this already exists, no new information that we need to worry about at this time. So again, looking at the true side of this statement, again, we're creating that record in SharePoint that generates a brand new alert. But we're also then creating that file of the original JSON return from the API. And this really has a couple of benefits. So really, it's not going to be any immediate action, but if we notice anything going wrong with our flow, it's a great resource to go back and look at the definition of the API previously, so we can help determine what's changed since the last time and how we might need to fix our flow to accommodate. And we're also running our log in SharePoint, say, hey, the flow ran, posting the message out in Teams, so our team can just confirm that everything is running the way that it's supposed to, and letting us know if there is an alert or not an alert, etc. So collapsing this all back down, again, just to give you an overview picture of the key steps, we have the get response from the API, parse the JSON, have an immediate failure if the JSON fails to parse properly. Let us know if there were any actual alerts in that return feature array, and if so, determine how many. Do we already have an existing? Is it a duplicate? Is it something new? Is it a change to an existing alert? So parsing through all those possible scenarios, trying to determine what's the most effective messaging out to our team to clarify what next action items they need to be tackling for this project. Power Automate is the invisible worker behind this project that helps keep everything moving. From logging data to notifying our staff and the client, these flows are what really make this whole project a success, automating critical steps from beginning to end. In this demo, I'll talk about the 4 flows that we have running. The first is scheduled to run every Monday morning to email a reminder to the upcoming on-call team. The second flow allows us or the client to manually create an alert for a watch period using Microsoft Forms. The third triggers when a new alert is posted and sends an email and text message to the on-call team. Lastly, each time an observation is logged, the client and team all get notified. This lets the project manager know that the observations are being completed on schedule, and lets the client know if water levels are high or if there are other issues that warrant elevating the situation to the next level. So now digging into our first flow, again, this one is fairly simple, just a couple of actions. It runs on a recurrence trigger that just allows us to send an email, again, every Monday morning. And the intent is then to just make sure we know who is on call and make sure they are reminded that they are supposed to be on call. So 10:15 every Monday morning, they're going to get an email. And this flow, before it sends the email, has to look up who is on call and actually get their email from our roster. So it does that with a simple get items action from SharePoint. And then the last step here is an apply to each, where it loops through then all the email addresses it finds in the roster and sends out a scripted message just letting them know, hey, you're on call. It starts again this Wednesday. Make sure you have all of your field equipment ready. You've tested the app. Double check you're scheduled. You're not traveling out of town. If so, now's the time to coordinate a backup. And other simple updates for things that might have changed on the site since the last time they were out there doing an inspection. So again, super simple flow. just to get people reminded that they're supposed to be on call this coming week and allow them to coordinate if they need to with other team members. So here is our second flow to talk about. It's basically a trigger for when a flood watch is created manually through the use of a Microsoft form. So the trigger itself is when a new response is submitted. So that's pretty straightforward. You actually find a QR code or a link or just go to our SharePoint site where we've got multiple ways where either ourselves or the client can access this form, and they are able to fill it out quickly, and it then syncs with the rest of our system to trigger this flow to make sure that that alert gets logged within our system. So the form ID itself here looks a little cryptic. That is just the way the form ID happens when you actually store your form within the team's group space instead of just on your account directly within the forms. But not a big deal. You just get it from the URL, copy paste here, and you can use it in your flow. So the very next action is always to get your response details, again using that ID, and then we can move forward actually using information from the form itself that was submitted. In this case, we have just a bunch of time zone conversions that we're doing and other time updates. One downside to using a form as a trigger is you can only put in dates. You can't actually put in a time for when we want a watch to start or a watch to end. So all we're doing in this segment of the video is pulling out the date, reformatting it the way that we need to for calculations, and then resetting it to start at 8 a.m. in the morning, and then the watch ending being at 5 p.m. in the afternoon. The assumption here is that we're either turning it on for testing, or we have another alert that we just want to do a couple of observations for something that's happening during that day, and we're most likely not manually creating an alert that would run in the evenings and weekends. So we just set it for business hours as a place to start. The last step then is just to create that record in SharePoint so that we have a new alert, and that will then kick off the next workflow that we will be talking about. This third flow is for when a new alert is posted to our SharePoint site and then sending out our notifications to our on-call team. So like most of the rest of these, our trigger is going to be when a SharePoint item is created. In this case, that can be either through the logic apps that created the record when the National Weather Service posted a flood watch to the API, or it can be from the previous flow that we just looked at using the Microsoft Forms when we actually then manually create an alert ourselves. Or even if we just went into SharePoint into the list directly and created an alert, this flow would get triggered and it would run. The next three steps here that we're looking at are all convert time zone. And again, that's really just to get stuff from UTC time into US Eastern Standard Time for when the alert was posted, the watch beginning time, and the watch ending time. And again, this is really just formatting for the emails that we're going to be sending out. So stuff is in day, month, year, and then our AM, PM, which is the format that we're used to here in the US. Before we can send an email though, obviously we need to get the list of who we're sending the emails to. So we do our SharePoint get items to look up those currently on call from our roster schedule. And then I've got a switch here, even though I've only got two categories. An alert is either a new alert or it's an update to an existing alert. In this case, let's just look at the update first because it's pretty simple. Is that if something has changed to an existing alert, we want to send an email out to our team letting them know that, hey, either the date and time of the watch has changed, the description of the area impacted has changed, or something else that they may need to know about. So we send an email, but then we also are using Twilio here to send text messages to our teams. This way, if staff are not currently sitting at their computer or actually have their work email on their cell phone, that they will also be able to register a text message phone number for us to send messages to. So we'll make sure that they get the messages when they need to, whether it's the middle of the day or, as some cases, it's the middle of the night. So on the left side of our case statement here, if the actual alert posted is a new alert, it still does the same messaging. It's going to send an email out to the team, and it's going to send text messages to the phone numbers that they have listed in our system. And so that's why a lot of these are wrapped in apply to each, because they could have multiple emails or multiple phone numbers per person logged to make sure that they get the messages in a timely fashion. But these messages here are pretty much the same thing, where it's letting them know, hey, there's an alert, here's when it starts, here's when it ends, and just making sure that the team is all coordinated on who needs to be able to do what next. But this last section here for a new alert does a few more things. Instead of just terminating and say, hey, I let everybody know there's a new alert, we also want to wait and double check to make sure an observation gets recorded. So there's an initial delay here until whenever the watch starts, and then there's an additional 4-hour delay just to give them some grace period, because you don't have to do an observation until within 6 hours. And so it's going to then check SharePoint to see, has there been an observation logged related to this alert? And it's going to do a compose here just to check the length of the values returned. And if that is listed as 0, meaning that nothing has been logged, then we need to send a reminder back out to our team and say, hey, we're getting close to the end of our 6-hour window. We need to make sure an observation is made. On the no side of this is basically just taking a little bit of a closer look and confirming that it truly is been completed, and then it sends the email out to the team saying, yes, thank you, an observation has been recorded. Please make sure that you're on target for the next 6-hour window. So lots of emails and text messages, but again, the point is to keep our team in the loop and coordinated in an automated way as possible, so we do not have to manually send emails, messages out to the team to let each other know that we are on track for completing our observations for that cycle. So our fourth flow here is for when a new observation is entered. And again, that's just being created a record in a SharePoint list. So same as the ones we've just looked at previously. And typically this will be done through the Power App, which I will show you in the next demo video. As typical as well, we're also doing some time zone conversion to kind of get our dates and our times in the right format that we need. In this case, mostly they're for evaluation within the flow, more so than actually formatting for reading in an email. But in either case, a helpful step to do at the beginning. Then we go ahead and get some other information for the alert related to this observation. Primarily in this case, it's the watch ending date, so we can make some decisions based on that later on in the flow. We also, again, go ahead and grab who is currently on call, so we know who we're talking to when we're sending out messages and alerts. Finally, we go ahead and calculate what is the next 6-hour deadline from when we just made an observation to now when the next one will be done. And here then we actually going to run on parallel paths. So the left-hand side is going to execute immediately, and then the do until is actually going to start looping, and I will talk about that in just a second to show you how that works. But the left-hand side, again, is going to be our standard fare. We're sending out an email message to our team, letting them know that an observation has been logged, which includes information about what they've recorded, so the height of the water, any notes, or any other points of concern. And that also then gets text message, and a very simplified message, honestly, to the rest of our team to make sure that they are getting the message. Again, usually this is unfortunately the middle of the night or the weekend, and not everybody's paying attention to their email, so we use a text message just to make sure our staff are notified in the loop, because they need to be able to work as a team. Now the do until is basically going to run on a loop with a delay in there for every 2 hours. And what it's trying to do is double check in SharePoint, has a new observation been logged for this alert since the observation that triggered the flow that I'm currently in. And I'm just using the date field here to be able to check that. And so it's going to keep every 2 hours, look for that information and determine if it found a match or not. And if it has, then again, it's going to return specific information, allowing us to then run a condition here in the next step to evaluate what we want to do next. And this condition is a little bit more complicated. I will hover over the formula here in a second, but really checking two different things. So is the new observation greater than the created date for the flow that I'm currently running? But then also is now actually after the end of the watch period, meaning we don't actually need to do another observation and it's okay, the flow can just terminate and be done. So depending on the outcome of that, it'll either just do nothing because we're okay, or it will send another set of reminders in email and text message format out to the team members, letting them know that, hey, it's been 2 hours, I don't see a new observation. The final part of this project to talk about is the Power App. This is designed to work on a phone and is how the on-call staff interact with the system in general. They can review historic information, active alerts, log new observations, and contact their teammates if they need assistance. In this demo, I will walk through the main screens of the app and demonstrate how a new observation is logged. I've turned off the flows for this demo, so I won't be accidentally creating an alert for our real project. Key features include the home screen, updating the on-call schedule, viewing alerts and observations, tracking the countdown clock to the next observation, and actually logging a new reading. So here's what the home screen of our app looks like. Again, big bold words there, flood watch. And in the center of the screen will either be red if there's an active alert or green if there is no active alert. So you get a quick visual cue of kind of where you are, and also just giving some time indicators there in the middle as well. If you're in the alert, how much longer until the watch period ends, and if an inspection has already been done, how much longer until the end of the next 6-hour window that the next inspection needs to be completed. So again, it tries to grab your attention if you're in the middle of an alert. If not, it would all be green, where the countdown clocks would all be hidden, and there would be a button in the middle where you could actually initiate a new alert if you needed to. We also have just a quick button here to open the emergency action plan. So if you need access to other site drawings or information included in that plan, you can download that quickly to your phone and go ahead and open up that PDF. The rotation schedule is also included here on the home screen for who is currently on call. So there'll either be the name or the picture of the staff depending on what we have available in their profile. One really cool feature though that you can do with Power Apps is I made all the photos push button enabled. So if you tap on a picture, it will actually launch the call feature on your phone and you can just go ahead and call them instead of having to go look up the phone number or scroll through a list in the contacts, etc. So just a fun feature to allow us to be a little bit more connected. And the icons at the bottom are all linked to the 4 different SharePoint lists that we've previously talked about. So team contacts, again, it's just the list of names, emails, and phone numbers. The roster schedule here just, again, highlights not only the current rotation, but then all the other rotation periods that we also have scheduled. And in this case, I'm signed up for a lot. So say I wanted to change that, I've talked to a coworker and convinced them to take over for next week. I could actually remove myself here, and if I had more names in the contact list, they would show up from that drop down and I would be able to add them instead. So clicking the check mark, it'll save that. Now when I come back to the schedule, it'll change to the question mark showing that it's currently unassigned. So quickly drawing your attention to the fact that someone needs to be assigned to these roles before we're ready to hand over for the next week. So moving along, looking at our other lists, we do have one that shows all of the alerts for our project. So the newest one being at the top, and then all the historical ones listed below, and they'll be tagged as either completed or active with basic information of when the watch starts, when the watch ended, how many observations were completed within that alert cycle. So just good summary information to have at your fingertips as you're trying to get an idea of what's happening with the project. And then if we actually click the little details button, it will take you to a filtered list of all the observations in the log that are specific for the alert that you selected. So just an easy way to kind of drill in and just see what's what for a specific alert. If you click the other button on the home screen like I just did to get to the log gallery here, it'll just show you all observations without previously being filtered. So you can still search them yourself, but you can also then just see down the left-hand side a quick glance of all your water surface elevations, so you can see and evaluate if the current alert is kind of more or less than previous flooding events. So great ways just to sift through some of the data available for the project. And back on the home screen, again, if we are like we are now in the middle of an active alert, you'll be able to click the View Details button and it'll take you to an entire screen dedicated to the active alert. You will see all the watch details at the top of the screen. If there were updates changing the watch starting period or ending period, that will also be listed there at the top. And then in the middle of the screen, you will see a list of all your completed observations, again with the newest one at the top and then older ones going down the side. The bottom reminds you of your watch countdown clock and your next observation countdown clock as well, just so you always kind of have that for awareness. Then if I wanted to log a new observation, it's going to automatically populate me as the observer since I'm the one logged into the app. It'll also automatically populate the title so it matches the alert specifically, and I don't have to type all that out or try to remember it. The observation date time does default to the current date and time, but it allows you to change it, again, just in case you're not actually physically standing there in the pouring down rain at 2 a.m. in the pitch black, that you can wait till you get back to your truck or potentially back to your office a few minutes later and log the result, but then properly date and time it. We do have, has reviewed as a question. Again, field safety is very important to us. We want to remind staff that if they haven't already, that they should pause and make sure they're reviewing the safety information for the site, especially if they have not been out to the site recently, since we get very few flood alerts. And then they're logging the water surface elevation reading. That is our critical benchmark value. And then providing any notes. Again, these get emailed back to the rest of the on-call team and to the client, so everyone can keep track of what is happening out on site without physically having to be there. And this allows us to know, hey, are things getting better? Are they getting worse? What additional actions maybe do we need to be taking if things are looking pretty bad? So, if you log the alert and you're not actually seeing evidence of that right now in the app, it does not actually refresh on the fly. We kind of have that as a manual option just to preserve bandwidth in the application. But now as I'm toggling through, you will see that it actually comes and shows up now in the list of observations. So again, try to keep everything within 1 or 2 clicks of the home screen for all the critical information that you would need to interact with the application and, make emergency phone calls, make decisions in the field, see where you are relevant to other observations that have been made for either this alert or for previous alerts to see how critical your current situation is. And then last but not least here, you can also create a new alert directly from within the Power Apps if you need to. And so if, the client is on site and they actually see dangerous conditions, they can use the app to just go ahead and log a new one, give it a title and a watch period for us to be attentive, and that will basically kick off a new alert cycle for us as well. So super excited to be able to have all of this into one app to keep us all on the same page and up to date, and make it as quick and as easy to use, knowing that, again, usually it's not ideal conditions. It's usually dark, it's cold in the winter, possibly pouring down rain while you're out there trying to make the safety observation. So a great app. It has been working fantastic for us since we've kicked off this project. And, I'm excited to be able to share this today and hopefully inspire others to do similar applications for your projects. Bringing everything back together, this approach successfully helps us manage our on-call roster, react quickly to new flood watch alerts, log field observations digitally, and keep the entire team and client up to date with automatic notifications. This improves our confidence that during a flood event, we will know if there's a problem with the dam and can take mitigating actions to preserve human life at risk and protect critical infrastructure. Thank you so much for attending this session at the Scottish Summit 2021. All presentations will be uploaded to YouTube after 14 days, so you can catch any that you might have missed. Thanks again, and I hope you enjoy the rest of the conference.